you guys.
So, hello and welcome to people here, and also welcome, since as we do these days, we're also streaming this around the laboratory, so to the distributed laboratory. So, and we'll stay close to our microphones. I should say we actually have the new sound system in this room, so that it can, when we do have Q&A, it can pick you up wherever you are, so we don't have to run around with microphones anymore. So this is. So, welcome everyone to this third event in the Director's Distinguished Women in Science Speaker Series. This grew out of, our initiative on diversity, equity, and inclusion, but it's also part of our celebrating the impact of science on society. We've been honored by two remarkable researchers to date, Jennifer Doudna and Jerry Richmond. So this time we needed to get someone who wasn't a chemist. That was a requirement. Today I'm very pleased to introduce our next speaker, who's a geophysicist who has led some of the most important scientific institutions in this country. The members of the National Academies of Science, of Engineering, and of Medicine represent the most accomplished researchers in the country. And Marcia McNutt was the first female president of any of the academies when she began serving as president of NAS 3 years ago. Yay. Yes, yes, absolutely. Yeah. And from my point of view, and it's time for the other two academies to catch up. And just 3 years into this role, she has become a leading advocate for science in an age of skepticism about science. At a time when science's voice has been perhaps muted, perhaps have other voices that have been louder. She has been a front runner in helping to shape U.S. science policy. I have had the honor and pleasure of serving on the National Academy's Committee on Science and Public Policy, and I am sure we will touch on some of those issues in our conversation today. From 2013 to 2016, Marcia served as editor-in-chief of the Science family of journals, as many of you know. She played a major role in building out what AAAS calls the front half of the magazine, which communicates the excitement of science to everyone, not just the technical experts. As one colleague observed, this has made a huge difference in the way that our communities have understood their opportunities and responsibilities for engaging with the public. Then, before that, in 2009, President Obama invited Marcia to join the group of scientists who are taking on leadership roles in the new administration. That included Steve Chu, Jane Lubchenco, and John Holdren. And she served as director of USGS, the U.S. Geological Survey, for 4 years. And as we'll talk a little bit about, USGS responded to a number of major disasters, including earthquakes in Haiti, Chile, and Japan, Deepwater Horizon oil spill, and Marcia led a team of government scientists and engineers at BP headquarters in Houston who helped contain the oil and cap the well, and we'll talk about that as part of our discussion. But before even that, Marcia McNutt was a local leader serving as president and chief executive of the Monterey Bay Aquarium Research Institute. And oversaw their research, and she was one of the people who made that transition at that point in her career from being a full-time scientist to being a leader of science. And she did a remarkable job of identifying what made, what were the opportunities of that institution and leading it into the future. But in the end, she's a scientist. She's a marine geophysics as her background, and she began her faculty career at MIT, where she became the Griswold Professor of Geophysics and directed the Joint Program in Oceanography, a course of study offered by MIT and the Woods Hole Oceanographic Institution. Her own research focuses on the dynamics of the upper mantle and lithosphere on geologic timescales, and she's had a remarkable career and many major ocean cruises, of course, was her. So she was the first woman to lead the NAS, the first to direct the USGS, the first woman to run the prestigious journal Science, the first to lead MBARI. So you get the pattern here. And perhaps the first one to roar into the MIT parking lot on a fiery red motorcycle to teach her course, I've been told. And she also has a passion for fast horses, and you can find out on the web about her, writing there. So she has received numerous accolades, and one of them is as a role model for young scientists everywhere. So please join me in welcoming to the stage the President of the National Academy, Dr. Marcia McNutt. Oh, thank you. Thank you. Take that. So what I thought we'd do is I'm going to, I have some questions that I think are the questions that you would be asking if you're here. So to get this started, and we'll do this for a while. And then at the end, we'll have some chance for people around the audience to ask well. So let me start a little bit at the beginning. So you were a physics major when you started.
Yes.
So as a physicist, I pay attention to that. So what led you to make that choice?
Well, I think that when I was in high school, I went to an all-girls school practically my entire life. And I had this amazing teacher in high school, Mrs. Hill. And there were only 4 girls in my class who took physics. And she just made us adore physics. And I'm sure there are so many scientists here in this room who think back to that one teacher who was such an amazing role model and had such an incredible impression on them. And for me, it was Mrs. Hill. She taught me calculus in high school, and she taught me physics. And physics just seemed so beautiful. I loved the fact that it wasn't sort of, it wasn't kind of. It had rules, it had laws. I adored physics, and I could imagine nothing better than being a physicist. Okay.
So then for graduate school, you went to Scripps,
yes,
which is this great institution at UCSD, but although it actually predates UC San Diego.
Yes.
It was the institution around which UC
yes.
San Diego grew.
It was, yes.
Scripps Institute of Oceanography. And this must have been a very exciting time.
Yes.
So what did you work on and why?
Right. So when I was about to graduate from college with my degree in physics, I had been thinking about, well, the faculty at Colorado College had encouraged me to go to graduate school. My plan had been to go to Sun Valley and be a ski bum. But
not a bad plan.
but they had other ideas and convinced me I should go immediately to graduate school. So, but my advisor, Dick Hilt, said, you know, I don't think, he said, you should go to graduate school in astronomy. He said, people are lining up for telescope time. And he said, I don't think you should go to graduate school in high energy physics because people are waiting for time for these new accelerators to be built. But he said, here, read this. And he handed me the very first article. It was written in Scientific American, and the first article that was written for a popular audience on plate tectonics. Oh. And it changed my life. I had taken geology courses at Colorado College and loved doing science outside, adored doing science outside, but I wasn't intrigued by geology as a career because it seemed so arm-wavy. All the beauty that I had loved about physics, because it was so simple and so perfect, was lacking in geology until I read that article by John Dewey. And plate tectonics, there it all was. It was all laid out. This simple theory for everything on Earth, for volcanoes, for earthquakes, for mountain ranges. And so I said, oh, well, now I know what I have to do. I have to go to an oceanographic institution because all the plate boundaries are underwater. And that is where I will combine physics with understanding the Earth. And so that's what I did.
Good. So, well, it worked out well, which got you to MIT on the faculty there. And your research really, that's really when you made your career in research, in some sense, really. You were also raising 3 young daughters as a single parent at that time.
Right.
And I think, I certainly, how did you manage to do all that? I think I would sort of like to understand that.
Yeah. Right. Well, so my husband died very suddenly when my oldest daughter was 6 and the twins were 2. So I remember at first thinking that, you know, just thinking that I didn't know how I was going to go on.
Yeah.
It was very difficult to think how I was going to manage everything. And, you know, Bob Bergeneau here was dean at MIT at the time. Tom Jordan was my department chair. And, you know, everyone at MIT was very, very helpful. And I got some good advice. Someone told me, don't make changes in your life. Don't make sudden changes that are going to add to this sudden change. So I decided, I had thought, how am I going to keep my home? How am I going to continue to raise these kids all by myself? But I made minimal changes possible. One thing that was really fabulous was we had a wonderful nanny who had come to live with us years before, and she stuck with me through this entire time. So the kids still had basically their 2 primary caregivers, me and their nanny. And we just made it through.
Yeah. No. Well, it turns out you made this fantastic career then, but then after a while you did make a big change.
Yes.
That is, you know, in the middle of that career as a research faculty, you decided to move to Monterey and become director of Monterey Bay Aquarium Research Institute. I had one of those changes when I went from being a faculty member at Santa Barbara to being director of Fermilab. Although I moved from Santa Barbara to Illinois, and I see you moved from Cambridge to Monterey, so you may have gotten something right there. But at least I know something about that situation of making what, in some sense, you know is going to be a big change in your life to move to that from your own research to helping other people with their research. So, how did you think about that?
Yeah, so that was an agonizing decision. I had so many people tell me to even consider leaving MIT was career suicide, that I must be out of my mind to even think about it. By that time, my children were in junior high school, and you know, basically the Boston area was all they had ever known. I loved MIT, loved my students, loved the people I worked with, but I had been there a long time. And so I thought, can I possibly adjust to going from doing my own research, which is, frankly, the greatest thrill you can ever get, to solve problems yourself and think, wow, I discovered this. That is so exciting. To a different situation where you're in research management, and so you have to somehow get your satisfaction vicariously by enabling other people's research. But I thought, you know, I've done this for 15 years, and look at all these students that I've turned out, and maybe I need to do something else. The other thing that went through my mind is I noticed, and you were part of this, Michael, you invited me to come and be on, I believe at one point, well, you and other people were inviting me more and more to come and advise other people on their research programs. And I realized what people are more interested in learning from me is my advice on their research. Rather than my research.
And that's right. When I was first Vice Chancellor, the first thing I did as Vice Chancellor is we had the largest institute reporting to me was the Marine Science Institute. And of course, the first thing I did was have a review of the Marine Science Institute and brought in a group of distinguished people, including Marcia came in, and it changed the way we went with that Marine Science Institute as a result of that review. So that was the first change.
So I realized that people really, what they care more about from me is not about my own research, but my opinion of everyone else's research. And I thought, he didn't pay me for that. In fact, no one pays me for my advice on everyone else's research, as long as I'm a faculty member here at MIT. But if I actually went into research leadership, now I'm actually getting paid. That is my job, to actually advise people on their research. So maybe I should actually go do a job where I'm getting paid for what other people think.
You're giving up our secrets now.
So that's what I did. I went there, and it actually, and in terms of the family, my children thought that they were, at the time, moving into Beverly Hills 90210 because they just thought California was all, one big television show. So that worked out.
So then you had a good long tenure at Monterey Bay Agrarian Research Institute, about 10 years. And then Sean Solomon, who a well-known, distinguished scientist, contacted you because he was working at the National Academy to think about who might lead USGS in the next administration. And one thing led to another, and you ended up actually getting a call about leading USGS.
So what had happened was Sean Solomon was put in charge of the National Academy's committee to recommend the next director of the USGS under the Obama administration. And so they put together, he called me up, and at first he said, we're just putting together a long list of people who would be willing to talk to the administration about taking on this job.
That's a slippery slope.
Yes, you've been there. So you don't have to say that you take the job. You don't have to say that you're eager to do it. All you have to say is that you're willing to talk to the administration about it. So I thought to myself, I'd been at MBARI, almost 12 years by that time. So I thought, okay, well, I'd be willing to talk to them. Little did I know how persuasive a person Ken Salazar could be. Oh, my goodness. And not only that, but he had a secret weapon, who was Frank Press. Oh, yes. And Frank Press, who was still in Washington at that time, was also equally persuasive in telling me that I needed to do that job. So anyway, that's where I ended up.
Well, first of all, when you showed up at USGS, from outside, what did you find? What was it like?
Well, first of all, I was totally pleasantly surprised at the USGS. It was just full of these wonderful scientists who adored the USGS. You hear sort of on the outside about government workers who maybe are taking advantage of working for the government or whatever. Oh my God, that was not the USGS. These are people who, even after they retire, come to work every day. These are people who ignore shutdowns to come to work. These are people who adore their job. The USGS had more 50-year pins than any other organization in government, even though they are by far one of the smaller organizations. And that's because people come to the USGS, they love it, and they stay there. When I was USGS Director, I actually gave out a 70-year service pin.
Wow.
70
I have not done that.
7 years. So these were people that just love the agency, they loved the mission, and they worked hard. They worked hard for the mission of the USGS. So that was...
Then at USGS, you had a few events.
Yes.
And why don't you might remind people what they were.
So my friends at NOAA started calling me the Master of Disaster.
No.
And that name stuck because I started in like early November, and then January was the Haiti earthquake. And then I had, after Haiti, there was the Icelandic eruption, Eyjafjallajökull. And then there was Deepwater Horizon. There was, I forget the exact order, the Chilean earthquake. Chilean earthquake. There was the Japan earthquake with the nuclear Fukushima meltdown. There was Superstorm Sandy. There was, an endless string of disasters. There, the West burned up, floods in the Midwest, the first time ever that every spillway was opened in the Ohio, Missouri, Mississippi river system. They even blew the levees in the Bird's Foot Delta with explosives that had been buried since the 1930s that flooded the farmlands in the Bird's Foot Delta. So there wasn't anyone even alive that remembered that those explosives were there except for the USGS. So.
Well, and probably the most sort of visible to the outside world of all those was the Deepwater Horizon.
Yes.
And you had a central role in that. So what was it like at the middle of crisis management?
So I think of all these disasters, of course, the Deepwater Horizon affected me the most. I remember a couple days after the well blew, and before anyone really had their arms around the magnitude of the disaster, Secretary Salazar put me on a plane and took me with him down there to assess what was going on. And we went to New Orleans, we went to Mobile, we ended up in Houston for what was going to be a 3-day tour of the disaster areas. When we got to Houston, he decided to leave me there to oversee the federal response and help BP with containing the well and other issues that were going on in BP's crisis command center, because he knew that I had had a substantial experience in deepwater intervention with all my time at MBARI, because MBARI was sort of like a NASA for the oceans. We spent a lot of time with submersibles and deep sea observatories and things like that. So he decided that I would be the right person there. So my 3-day trip to the Gulf turned into a 3-month deployment at BP headquarters. And that's where I worked very closely with Steve Chu to work on all the interventions that finally resulted in installing the capping stack that closed in the well.
Did it occur to you that this might not be stoppable at the time? Or was it clear along it was just a question of how to do it?
Right. We had a very ordered system of interventions lined up, and we were confident that one of them would work. BP's view was that they were going to start with the ones that they felt were, what would be the word? The ones that they felt were lowest risk.
Yeah.
But we were fairly sure that in the lineup, one of these was going to pay off.
Okay.
Yeah.
So then you did a 4-year tour that was a rich 4-year tour at USGS, and soon after that you became editor-in-chief of Science.
Yes.
Which is familiar to many of the people here. And so just to pick out one of the many things going on there, this is a period when the integrity of science was being questioned, when the reproducibility of science was certainly, papers were being, retracted papers were getting a great deal of attention. So tell us a little bit about what it was like managing that.
So I remember when I went to interview for the position of editor-in-chief of Science, the committee that was choosing the editor said, what issues would you take on as editor-in-chief of Science? And I said, I believe the most important thing that I can deal with is the integrity of science. And as editor-in-chief of Science, my most important task would be to worry about this issue of reproducibility. Well, I was chosen for the job, but I remember Alan Leshner, who was the CEO of AAAS. He came up to me later, many years later, and he said, when you were talking about integrity of science and reproducibility, he said, I didn't think that there was a there, that was a really going to be an issue. And he said, I'm really glad that you took that on. And I'm really glad that science got out in front of that issue. Because after I became editor-in-chief, I raised some money from some private foundations. I invited Nature and some other journals to join us. And we started a campaign to look at what were the sources of irreproducibility in science and what we could do to get out in front of the issue. What were the issues that were of a computational nature? You know, simply bad statistics, inappropriate p-values, that sort of thing. What were the issues that had to do with actual, fraud, which is a very small part of it? And what were the issues that just have to do with complex systems? That some of the science just is dealing with not understanding what are the dependent variables and what are the independent variables when one goes in to try to understand, get your arms around a very complex problem, such that you might assume you have controls over everything, and in the end, you really don't. And because you don't, there's hidden variability in your experiment that you don't know exists.
And although fraud is, as you say, rare in science, self-deception is not so rare.
Exactly, exactly. And, that's something that, though, with careful, we put out some very clear guidelines on things like blinding,
right,
and things like that can nevertheless help with self-deception.
Right. So then in your most recently left that job to become president of the National Academy of Sciences. So I should say in that role, there's a committee on public policy that meets that I serve on that Alan Leshner is now chair of. Mm-hmm. And much of what we're talking about are these issues again. Mm-hmm. And one of the things that there's actually a new advisory board for research integrity. So what's that going to do? How does that work?
Yes. The research board for scientific integrity actually hasn't been stood up yet, but it's something
it's still an idea.
Yeah, it's still an idea that we're talking about. So what the idea behind this research board for scientific integrity, which has been actually recommended in several Academy reports over the years is the idea that there would be advantage to the research community to have a neutral place to go where a group of people worries about the culture and the processes that uphold the highest standards for science on an enterprise basis. So right now, there are smaller groups that might deal with publishing ethics, or that might deal with ethics for human subjects, or that might deal with ethics for different fields. But no group that looks across the entire, from the input funding to the output in the publications, as to how all these pieces fit together and work together. And the idea of this board is that it does not investigate complaints, it does not met out punishments, but it serves as a resource to everyone of how we can raise the tide for all ships to improve the quality of what we're putting out.
Okay. So you've had this very rich career. So out of that, what was the most important event or events in shaping that for you?
Yeah. So it was interesting. When I was down in Houston and we finally capped the well and managed to do a static kill because it was no longer flowing, there was a young Coast Guard officer who asked me as I was sort of packing up things because it was finally time after more than 3 months in Houston to go back to Washington. His name was Joe Kuzak, and he asked me, how has this oil spill changed you? And I remember thinking about it for a minute, and I said to Joe, I don't think it has changed how I view how I'm going to spend my time, because I don't think I will ever again be able to work on something that doesn't really matter. The oil spill had lifted up for me the importance of working on things that were really significant. Because that oil spill, I had seen how it affected the environment, how it affected people's livelihoods, how it affected the economy, how it had the potential to affect the health of people in the region, how people were waiting for daily reports on the flow rate, on opening of fisheries, etc. And I thought, this is science informing informing public policy that really matters. And I don't think I'd ever be able to go back to doing something that people didn't care about. That at most there would be 5 people that would read and understand the paper, and that would be it.
Yeah, great. So another thing at the National Academy that we've all been dealing with is, well, diversity of science, diversity of the academy.
Yeah.
And to some extent, I think that's something that I think, well, many of us, and you certainly have been dealing with through your career.
Yeah.
So looking at that from where you are now, what progress has been made? What progress hasn't been made? How do we make progress in the future?
So I'm totally convinced that we have to double down the effort to make progress at all levels, everywhere we can. So let me talk first just about the Academy.
Yeah.
So at the Academy, people will be probably surprised to hear that my council is more than 60% female. So, you know, when you think of the fact that the Academy is mostly a male organization, I think the membership is more than 80% male. When we have an election and we elect who those more than 80% men want to lead them, they want the women sitting around the table making decisions. So you might ask, why is that? Why do they predominantly, when they get a slate of 2 candidates, they could ask this guy or they could ask this woman, who are they going to vote for to lead the Academy? Why do they want the women? So, you know, I'm not really sure. I'm not sure everyone here has their views. I've asked some men. Here's what I'm finding. Deep down, everyone, men and women alike, have had a variety of experiences with their fathers. But everyone tells me that mom gave everything for the family. And she would put her own needs last in order to make sure that the best decisions were made for her family. And so that's my thought about why the women are sitting around the table, because everyone trusts that they are not going to vote what's best for Stanford University, or what's best for the University of Chicago, or what's best for biology, or what's best for chemistry. They're going to vote what's best for the entire organization. The other thing is, we are electing women to the National Academy in record numbers, whereas it's less than 20% that are members right now. Last year's class of new members was almost 30% women. And I think we're going to bust that number by an amazing amount this coming year.
Okay.
So I think that's very good. But I think the most important thing we've done for women is our new report on sexual harassment in science, engineering, and medicine that came out last June. This report is getting a lot of traction in not just in STEM, but in fields all across academia, and is even being picked up outside of academia. I was sitting at dinner next to the head of the NCAA and talking to him about the report, and he said, wow, all of those issues we've got in the NCAA. And he immediately wrote down the URL of the report, and he said, we've got to read these findings, and we've got to take up these recommendations. So I think that until the culture changes within institutions following the recommendations of this report, we probably will not have equity for women in our institutions. And so the Academy is certainly practicing what it preaches. We have a new code of conduct, which not only deals with scientific misconduct, but also sexual harassment, bullying, etc. And along with it, an enforcement policy. So we're excited.
Right. So that was going to be my last question. So I would like to give people in the room a chance to ask questions. As we said, they actually can set up the microphones to pick you up now. He tells me. So we're going to ask for questions. So Roger will start.
Hi. Thank you very much for your comments. I guess my question involves the academies and their giving advice to the government.
Yes.
So 2 recent issues that could involve the Academy. First is the proposed review by the National Security Council of the National Climate Assessment that appears to be focused on engaging skeptics. The second is the definition of sensitive topics regarding national security, economic security, while still trying to maintain the openness of universities and labs.
Yeah.
So given those two topics, are those kinds of topics that the academies would jump in on and help as those processes are in place in other parts of the government?
Yes.
So,
I would like to say more, but I'll just leave it at
okay, Mina.
I have two very specific questions, and I don't mean to take everybody's time. But one question I have for you, how did your father treat you? And what is the significance of fathers in making daughters that can make a difference? I am a great believer in this. And one of the things that I have gathered, not enough statistics, but personal statistics. And how was it for you? What child are you, and how did your father treat you?
So I am the second of 4 daughters. There hadn't been a boy born on the maternal side of my family in years. So I come from a very strong maternal line. My mother was fond of saying that my father couldn't say no to me. I don't know if that helps. And because I didn't have a brother, I would say my father sort of treated me like his son. I was the one who got up at 5 in the morning and went out to the duck blind with him. I was the one that, got up and mowed the lawn, so.
This was true of me too. I was the second daughter of 2 daughters, and I was treated very much like a boy. And but I do think that fathers make a huge difference in how their daughters behave. Now, if I may, I have a question about MIT,
yes.
Your alma mater. Why does it have so few women after all of these years? And there is another one which is even more important, that the relation of people who have to withdraw their papers, and they have shown that the papers were made up. What does MIT do about those things? Do you know about these two?
So I'm not sure I really can talk much about MIT policy. One thing I do think is that the system, one thing about this research integrity advisory board we were talking about is how do we get more teeth into the process of retractions? Because right now, if a journal finds that work is flawed or suspects that it is, and they request that a university do an investigation, the journal can't do the investigation. They don't have access to the labs, to the people, to the notebooks, to anything. And what they find is that some universities do a really good job of getting in and getting to the heart of the problem. Other universities have no incentive to do it because it's embarrassing to them, and so they do nothing, or they cover it up, or whatever. And so I'm very, stories I could tell you from my time at Science Magazine of universities that hopped right to it, who got us great information, beautiful documentation that allowed us to write a great retraction of a paper, and other universities to this day that I've been, 6 years out of science, and still know that the university has not given science the information to retract the paper, and I had to do editorial retractions on those papers.
Right. Okay, yes?
A question about the role of the academies in guiding the government balance of funding for research. It's specifically recognizing the academies are advisory, do not make policy.
Right.
What can their role be with respect to what we invest in space research versus other initiatives?
Right. So, to my knowledge, I don't believe the Academy has been asked that question. Just to be clear for everyone here, the Academy does not advocate for science or scientists or whatever. So we do not go out and say, there should be more money for science, or there should be more money for space research, or there should be more money for this, that, or the other thing. Because we want to be able to be viewed as a non-partisan, independent voice, that if the government, in fact, as a real example, if the government came to us and said, what would the impact of a 10% increase of funding to science be, we could say honestly what the impact would be, because we haven't said, oh, funding has to increase for science. But to my knowledge, we haven't been asked the question, if funding were reallocated from this field to that field, what might the deleterious effects be on this field, and what might the positive impacts on that field be? I haven't, seen that.
Many, of course, the National Academies do many of these studies in fields, the decadal survey for astronomy and for physics and for, but to my knowledge, actually, I can't think of one where they were actually looking across the landscape of science at puts and takes from one to the other.
It's usually at the National Science Board level that those trades are made.
Yeah.
But I honestly do not know of a case.
No.
Thank you.
No. Yes?
In addition to do significant work, what other advice would you offer for early career researchers?
All right. If I had to say, and I told this to the early career researchers earlier today, one thing that certainly made a difference in my career was, I think that far too many people plant their feet at one institution and stay there forever and don't get the advantage of different places, different organizations, new missions, new ways of thinking, new problems to solve. After I'd been at MIT and I went to MBARI, I realized I'd probably been at MIT too long. And when I left MBARI to go to the USGS, I realized I had probably been at MBARI too long. Every time I moved to a new institution, it was almost like repotting a plant. It was like this adrenaline rush of new people, new ideas, new mission, new things to do. So I would say don't get so rooted in one place that you can't go forth and try something different.
Okay, I think I'm going to sort of have a chance to end on that note, because that was actually a good one. And I want to say, for one thing, also, besides this discussion today, Marcia did take care, we had her talk to some of the early career scientists this morning, and so we've taken full advantage of her being here today. She's been working hard for us for free, and but I really want to.
But all of you always work for me. That's what I say every time I go any place. It's all full of volunteers for the Academy. So on behalf of the Academy, thank you for all you do for the National Academy.
So please let us thank Marcia. And I want to say I thank you all for participating, both people who are here and streaming online. And we certainly look forward to doing another one of these in 6 months or so when we have the opportunity. But this will be a hard act to follow. So thank you very much.
Thank you. Thank you.